Hello, Zaid, can you hear me?
Yes, I can hear.
Hello, everyone. I hope you're doing well. So welcome back to MDS Talks. As always, we have our amazing guest, Zaid Ahmad Awan, with us. And today we are going to talk about a very interesting topic about machine learning. So welcome back, Zaid.
Hi, Zaid.
Hi, so should we start?
Yes, we can go ahead.
Okay. So, hi
Please,
everyone. Please go ahead.
sorry for interrupting. I just want to say, please, can you share your screen?
Yeah, I'm sharing my screen. So, just a second. So, my screen is visible.
Yes.
Okay. So, hi everyone. Today we'll have a session about uh, the basics of decision tree and generative AI. So, we'll start with the conventional ML, and then we'll jump to generative AI part, where we'll learn the basics of how we can use OLAMA to run a large language model locally, and how we can use an open source vector database locally to classify the documents. or to create a RAG pipeline on top of that. So there are two parts of this session. The first part is related to the classification, and that's why we have to understand the nitty gritty of the classification. So to understand the nitty gritty of the classification, we'll start with the decision tree, how we can classify by using decision tree. So decision tree is a very basic algorithm of machine learning in which we'll try to classify different objects or different classes. So as you can see on my screen, we have a table, and in this table, or you can say we have a data set, a very small data set, and in this data set we have three columns. The first column is gender column, and the second is age, and the third column is application column. So let's say the third column is our target column, and first two columns are our independent column, which we'll be using to train our ML model. So to train the ML model, there are different techniques which we can use by training a decision tree based ML model. So what we can do is we have to use, or we have to pick a particular column. For example, let's say I can pick age or I can pick gender. So I'll start, splitting the data set based on that column. So by using any column, I have to pick a column and I'll use that particular column as a root node. So as you can see in this slide, I am using age as a root node, and I started splitting my data set based on the age. So on the right side of the data, on the right side of the tree, you can see if age is greater than equal to 20, or if age is less than 20. So if age is greater than equal to 20, then I'll split the data set more on the basis of gender. Otherwise, if the age is less than 20, then I can predict that the user will use this particular application. So I have to predict uh, which application user might use. So if the age is less than 20, I can predict that the user will use this particular application. Or if the age is greater than or equal to 20, I have to split on the basis of gender. Then if the gender is female, then the user will use WhatsApp, and if the gender is male, the user will use Snapchat. But in decision tree, we don't split based on the hunch or based on the domain knowledge. So we have to split, we have to make these splits, or we have to choose a particular column uh, which is giving us more information or more score. So by using that score or that information, we can split these columns. So what are those techniques? I'll explain those techniques one by one. So there are some terminologies which we'll learn before learning those techniques. So first of all, decision tree is a supervised learning algorithm. So there are two types of, two different types of ML. One is supervised and second is unsupervised. So if we have labeled data set like this, I already have label, and that label is provided me in this column app. So this is my target label, right? This is my target column. So if I have target column, then that type of data set will be considered as labeled data set. And if I use a labeled data set to train a machine learning model, so it will be, we can call it supervised machine learning technique, right? And if we don't have labels, for example, if we don't have any target column and we have to train an ML model, so that type of machine learning technique is called unsupervised learning. So in unsupervised learning, we have different algorithms like k-means, hierarchical, density-based clustering. So different clustering algorithms. These are unsupervised learning algorithms. So same goes for the large language models. So we use raw data, and we use unsupervised learning technique in pre-training, in pre-training stage of the large language model. So in pre-training, we don't have any labels of the data. We have the raw data. maybe we extracted the data from the internet, or maybe we are using some books, right? So those type of data sets are not labeled data set. So that's why we call them unsupervised learning technique in pre-training part. So after pre-training, if we have to fine tune the large language model, then we use a supervised learning technique. We create a data set of prompt completion. So in prompt completion, we have the column of our target variable, that is completion column. So that's why we call it supervised learning. So same goes for the decision tree. In decision tree, we do have a target column. That's why we call it supervised learning technique. So first of all, we have to learn these important terminologies. So the main node which we can use to split, which we can use as a starting point to split the tree, is called root node. So it represents entire population or sample, and then we further divide this entire population and sample into homogeneous sets. So homogeneous sets means we don't have mixture of classes in a particular set. We try to reduce the mixture, and we try to create a homogeneous set. Then there is a splitting criteria. So we can choose a splitting criteria, like the age. In age column, we selected the splitting criteria. If the age is less than 20, then go to left side. If the age is greater than or equal to 20, then go to the right side. Then there are some decision nodes. So this is my root node, and these are my decision nodes. So after splitting, I'll create some decision nodes, and then we'll have some terminal nodes. In terminal nodes, we'll have we can also call them leaf nodes. So in these leaf nodes, we'll have some some records, maybe 20, 30, 40, 50. So in those leaf nodes, we'll have a homogeneous set of records, and we can use those records to make a decision, right? And then there are also some important terminologies related to pruning and branch, subtree, or parent-child node. So pruning is, you can, I mean, if there is a concept of overfitting and underfitting in the machine learning. So if I have to control the depth of the tree. So if I'm not controlling the depth of the tree, and then I can face some kind of overfitting as well. So I have to control the depth of the tree, so I decide the depth, or I can prune a certain branch, or a sub branch from a decision tree as well. So these are some important terminologies. So we'll see through an example. So let's say we have a sample of 30 students, and with three variables, like gender, which is boy and girl, and then class, ninth and 10th, and then the height, which is from 5 to 6 feet. So 15 out of these 30 play cricket in layer time, right? And now I want to create a model to predict who will play cricket during layer period. In this problem, we need to segregate students who play cricket in their layer time based on the highly significant input variables. So first of all, we have three columns, and this is column number one, which is gender, and this is column number two, which is class, and this is column number three, which is height. So by using any of these column, we need to start splitting that decision tree. So let's say I can use gender, I can also use height, I can also use class, but I need to define some criteria that which column I have to use. So for example, if I split based on the gender, so total we have 30 students, and out of those 30 students, 50 out of those 30 play cricket, right? So let's say total students are 30. So if I split based on the gender, so then all the females in this part and all the males are in this part. So 50 or 15 out of 30 means 50%. So 50% of the students from the total population, they like to play cricket, right? But from the female students, so we have, let's say, we have 10 female students and we have 20 male students. And from female students, we only have, 20% of the students are playing cricket. So we can say that 2 out of 10 these females are playing cricket, that's 20%. And 13 out of those 20 male students, they play cricket, so 65% of the males are playing cricket. So if we split on the height, so let's say I'm splitting based on the height, so I'm saying that split this tree based on the height 5.5 feet. So if I split based on the height, so I'll get, some number of students on the left side and some number of students on the right side. So I'll get mix based on the gender. Like for example, let's say I got total 12 students. So out of those total 12 students, only 5 students like to play cricket. So that is 42% of the students. And then I got 18 students on the right side, and out of those 18 students, only 10 students likes to play cricket. So that is 56% of the students. So in similar fashion, I can also split based on the class. So if I split based on the like class 9th and class 10th, then I got 14 student on the left side and 16 student on the right side. And out of those 14 students, 6 students likes to play cricket, so that is 43%. And 9 students likes to play cricket from class 10, that is 56 percent of the students. So based on this information, can I decide which column is the best column which I can use as a root node, right? So I cannot decide right now. So there are some different criterias which we'll be discussing. So those criterias are Gini index, information gain, reduction in variance, and chi-square. So we'll try to learn one. Rest of the techniques can be learned through YouTube or some other resources. But in this session, we'll try to learn at least one or two techniques. So let's say we can use Gini index. The formula of the Gini index is uh, the square of the success and square of the failure. So this is the formula: the square of the success and the square of the failure. So if you take summation of probability of the success and probability of the failure, you'll get a weighted Gini. So that weighted Gini score can be used to split these trees. So for example, in this example, if I calculate the Gini of subnode of female, so for example, let's say I've splitted this tree based on the gender, right? So based on the gender, I splitted this tree. So total students are 30. So out of those 30, 15 students are 15 students likes to play cricket in their leisure time. So that is 50%. So I splitted this based on the gender, and in the female subset, I can see I got total 10 students. So out of those total 10 students, only 2 students likes to play cricket, right? So what will be my failure rate? So just let me. So the probability is from 0 to 1. So 0 mean, 0% probability, 1 mean 100% probability. So if I have 10 students, 10 female students. So out of those 10 female students, only 2 likes to play cricket. So what is the probability of being a female and she likes to play cricket? That is that is 2 by 10 by 2. Sorry, 2 by 10. Okay. So that is 20%, right? And what is this is the probability of success. And what is the probability of failure? The probability of failure is, so if this is 20%, so I can simply minus 1 minus 0.2. So 0.2, so that will be 0.8. That will be 0.8. So the probability of failure is 0.8 and the probability of success is 0.2. So the formula is p square plus q square. So this is the formula. So the formula will be 0. So it will become 0.2 multiplied by 0.2 square of the success plus square of the failure, 0.8 multiplied by 0.8. So that is 0.68. This is the Gini score of one node. Then I have to calculate the Gini score of the male node. So I have 20 students in this male node. So out of those 20 students, 13 students likes to play cricket, right? So that is 65%. So 65% of the males likes to play cricket in their leisure time. So the probability of the success is 0.65. So I can take square of the 0.65 plus I can take square of the failure. So how can I calculate the failure rate? That is simple, that I can subtract 1 minus 0.6065. So I can subtract the success rate from 1 and then I'll get the failure rate. So I can take the square of the failure rate as well. So this is the Gini score of the male node. So then I have to calculate the weighted Gini. So what is the formula of the weighted Gini? So the formula of the weighted Gini is 10 divided by 30. So 10 is total females are 10 out. Let me write the formula here. So the formula is, I mean, total females. So that is total subset 1 divided by total multiply by Gini score of subset 1, right? Plus then total of subset 2, total of subset 2 divided by total and then multiply by Gini score of subset 2. So this is the formula. So the total of subset 1 is 10 females and total students are 30, and then I can multiply this with Gini score of subset 1. So the subset 1 Gini score of subset 1 was, so 10 divided by 30 and the Gini score of subset 1 was 0.68 plus total of subset 2. The total of subset 2 is 20 students divided by 30, 30 total students, right? And then multiply by the Gini index of this particular node. So this is how I can calculate the Gini index. So this is the Gini index of column gender, right? And then I'll calculate the Gini index of the class. In similar fashion, I calculated the Gini index of the class and that is 0.51. And then I can also calculate the Gini index of the height. So based on these three informations, I can use the column with the maximum Gini score. So under the hood, decision tree uses those columns with maximum Gini index to split the further columns, or to split or to create the further nodes. Then there is another formula, that is information gain. So the information gain is nothing but entropy. So if you are familiar with cross entropy, so this is just like cross entropy, and in entropy we'll calculate by using, so this P is success, so we take the negative of the success and then log base 2 and then the success rate minus negative of the failure log base 2 and then the failure. So in this formula we're taking the summation of the square of both success and failure, but in this formula we are using log base 2. So just like the Gini index, in information gain we use log base 2 to calculate the entropy. So we'll calculate the information gain of all the columns. So like if we have to calculate the information gain of the gender column, what we can do is, so we out of these 30 students, 15 student likes to play cricket, so that is 15 divided by 30, right? So 15 divided by 30 is the probability of playing cricket. Then log to 15 divided by 30 minus, so rest of the students are also 50, that is the failure rate, So 15 divided by 30, log 2 15 divided by 30, that is 1. So we got 100%, right? And then we can also calculate the entropy of the female node. This is the entropy of the parent node, right? And then this is the entropy of the female node. So the entropy of the female node is 0.93. And then we calculated the entropy of the gender, which is weighted entropy of both female node, male node, and parent node. So 1 is for parent node, 0.72 is for female node, and 0.93 is for male node. So we will use these three entropies, 1, 0.72, and 0.93, to calculate the weighted entropy of these subnodes. So this is the formula to calculate the weighted entropy. So 10 is the number of females. So 10 is the subset. Total of subset divided by total students, multiply by the entropy of that particular node, that female node. So in similar fashion, we divided 20 by 30, and then we multiply with the entropy of the male node, and we calculated the weighted entropy of gender. So this is the weighted entropy of gender. So this is basically the information gain of gender column. So in similar fashion, we can also calculate the information gain of this class column, and that is 99. So the information gain, weighted information gain of class column is higher than this gender column. So we can use class column to split this tree. So this is the second formula, and this is the third formula, that is chi-square. So in chi-square, we calculate the chi-square by using this formula, that is actual minus expected square, and then under root of the expected. So this is actually actual minus expected. So actual minus expected square, and then under root of the expected. So this is the formula of the chi-square, right? So we use this formula to calculate the chi-square. So in similar fashion, we calculated the chi-square of each column. So we calculated the chi-square of gender, and we calculated the chi-square of class, right? So based on the chi-square, we can split those columns. Like with the column with the higher chi-square can be used as a root node. So this is how we select the root node. So there are some other things other than selecting this root node. So let's say this is the root node. So let's say this is the root node. So we use three different formulas. Formula one is, Gini index. Formula two is information gain. Formula three is chi-square. So out of these three formulas, we used any formula. Like we used formula information gain to choose the root node, and we selected gender as a root node, right? Then we started splitting. So this is the first split. So after first split, we have to choose rest of the columns. So let's say I have gender column, then I have class column, then I have height column, right? So I have three columns. So first, the most information gain I got is for gender, right? So I use gender as a root node. Then I have to pick from these two columns. I have to pick a column to split this further. So let's say the height is having maximum information gain. So I'll choose height to split from here, right? So I'll choose height. So I'm saying if gender is female, go here. If gender is male, go here. So then I choose height. So based on the height, I'm saying if height is less than less than 6, let's say, go here. And if height is greater than 6, go here. Okay, greater than 6 go here, less than 6 go here. And here I can also split based on the height. Like if height is less than 5.5, go here, and if height is greater than 5.5, go here, right? And maybe I'll treat this node as a decision node. So this is my terminal node. And then I can also split based on the class further from this. So if like class is 9, go here. If class is 10, go here. So all these nodes will become my terminal node. So these are my decision nodes. So then you also have to decide at least how many number of records you want to contain in a particular decision node. So if I can set this as a hyperparameter that I need at least 50 rows in each decision node, right? If I got 50 rows here, then stop splitting. So uh, so what I mean when I say 50 rows, so at least I need 50 record in each leaf node. So for example, after splitting, when I came here, so the total records were, let's say, 50 here in this leaf node. So I cannot further split this node. So this node will be treated as a decision node. So what you can control the depth of the tree to overcome the overfitting. So you can control depth a. So this is point number one. So you have to control the depth. Why? Because you don't want your model to become overfitted. So overfitting means, so your model is performing very well on your training data set, but your model is not performing very good on your testing data set. So for example, let's say you trained a model and on training set you got 95% accuracy. So this 95% accuracy is for the training data set, right? And when you're testing your data on your test data set, you're getting, let's say, 75% accuracy. So it means your model is performing very good on your training data set, but your model is not performing very good on your testing data set. Your model is not able to generalize. So in this type of scenario, we can say your model is overfitting. So if we are not controlling the depth of the tree, we can face this type of scenario. And the second scenario is underfitting. So underfitting means your model is not performing very good on your training data set. So let's say you're getting 70% accuracy on training, and maybe you're getting 60% accuracy on testing data, right? So or you can say you're getting 40% accuracy on training and you're getting 30% accuracy on your testing data set. So this type of scenario is called underfitting. So underfitting has nothing to do with the depth. So you only face overfitting if you are not controlling the depth. So what is the depth of this tree? So this is level 1, level 2, and level 3. So we have depth 3. So 3 depth. So we have to control this depth. This is the hyperparameter. So we have multiple hyperparameter. One is depth, and the second is number of leaf nodes. So number of leaf nodes or the records in the leaf nodes. So you can control these hyperparameters to control this type of scenario, that is overfitting. So once you train your model, so once you are done with training your model, so you'll get a confusion matrix. So in confusion matrix, so for example, you'll get a confusion matrix. So that is true positive, that is true positive, this is true negative, so this is false positive, and this is false negative, right? So how you measure the accuracy? Your accuracy is nothing but true positive plus true negative plus true negative divided by total number of records. So for example, let's say I have a confusion metric like this, and in this confusion metric, the total number of records was 100, let's say 100, and I got 60 here, I got maybe 35 here, and then I got 5 here, 40, and then no, 0 here maybe, right? So what will be the accuracy? So the true positive is 60, the true negative is 35, false positives are 5, and false negatives are 0. So the accuracy will be 60 plus 35 plus 35 divided by 100. So that is 95%, right? Right? So this is how we calculate the accuracy. This is for binary class. So true positive is for positive class, true negative is for you know for the negative class. So for example, you have to classify either a document is valid or not valid, right? So you have two classes. So you can say one or zero. So you have two classes and you are having 100 documents. So out of those 100 documents, it correctly classify the 60 documents as valid. So 60 documents are classified as valid documents, and 35 documents are classified as non-valid documents. So by using this number, you can calculate the accuracy. But you have to be very careful about this false positive and false negatives. So by using this false positive and false negative, you can calculate recall and precision. So what is recall and precision? So let's say I have trained a machine learning model to detect or to diagnose the person with cancer, right? So my model is perfectly detecting the person's having cancer, but there, there is some there are some chances of error as well. So for example, a patient comes in and he's not having cancer, and my model detected that he or she may be having cancer, right? So this is scenario number one. The scenario number two could be uh, mm, there is a person who is having cancer, but my model was not able to detect that. My model was saying that he or she may be not having any kind of cancer. So in this medical scenario, the second scenario is dangerous, because the first scenario, if my model detected cancer and the patient was not having cancer, so the patient will go to the lab, and when they'll run some test, they'll say no, you are clear, you don't have cancer, right? But if a person is having cancer and my model is saying no, you don't have cancer, so maybe that person will not go to lab, and maybe after few months, his or her condition will be deteriorate further. So that's why it varies use case to use case. Either false positives are important for you or false negatives are important for you. So this is it about decision tree. Let's move further for the demo, where we'll classify some documents and we'll create a RAG pipeline by using Olama. So for that, what you have to do is go to a website, write Olama, and this is the link of Olama. So I'm sharing this link. So on this website, you can download Olama setup. So you'll get a exe. So you can download from here for Mac OS, Linux, or Windows, right? You'll get exe. Just let me show you what type of exe it will be. Okay. So click here and download. So as I have already downloaded this exe, so this is 198 MB file. So by using this OLAMA, you'll be able to run any kind of large language model, not any kind of large language model, but some open source large language models like Llama, Mistral, Phi 3, and Gamma. So you'll be able to run these models locally. So once you are done with downloading this exe, you can simply double click and you can install this. And once you are done with the installation, you can go to the terminal and you can write olama. Okay, so let me go to the, so click here on the models. So you, as you can see, you have different models like Llama 3, Phi 3. Phi 3 is the latest open source model launched by Microsoft. It is state of the art with 3.8 billion parameters. So this is Phi 3. And then Llama 3, then this Wizard LM, Mistral, and then Gamma, right? So we do have Llama 2 and Code Gamma, different models. So you can select any model. Like if you go to Llama 3, so you'll be able to see this command here, this command, olama run llama 3. So from this drop down, you can download the latest version, is the recommended one, which is 8 billion parameters. So this is 4.7 GB model. And if you wanted to use 70 bill parameter model, you must have at least 80 GB of RAM. So because this is 40 GB, the size of this model is 40 GB, so you must have at least 60 to 80 GB of RAM. So I'll recommend that you should use the recommended one, the latest one, right? And then you have the instruct model, then 70 will instruct. So there are number of models, right, from llama series. And then if you go back and go to this Phi 3, so in Phi 3, you get different models. So Phi 3 is the smaller model, and you have the quantized version of these models, and that is 3.8 billion parameter. And this 3.8 billion parameter Phi 3 model comes with the size of 2.3 GB. And then this is the mini instruct 4K, and it comes with 7.6 GB size, right? So what you can do is you simply can copy this command. So you go to the terminal. Okay, so you go to the terminal, you can type run, and then you can type phi 3, or you can simply copy this command, right? You can copy this command. So first of all, you have to download the olama. So once you are done with downloading, so you have to run this exe. So you have to install this olama setup. So once you are done with the installation of this setup, go to the terminal and run this command olama phi 3. So there are three commands. Let me write those three commands here. Olama run and model name, right? And olama pull model name, and then olama list, olama list, right? So if you have already downloaded any model, if you will run this command, it will start that model. And this command, if you don't have this particular model, like if I don't have phi 3 or llama 3, so if I'll run this command, it will first download that model and then it will run this model. So by using this pull command, you can only download the model, but you cannot run the model by using this pull command. And this is olama list. By using this command, you can simply list down the models. So for example, if I have already downloaded some models, so if I'll run this command olama list, so I have three models. So that is mxbi embed large. So this model is comes with 700 or 669 MB size. So this is embedding model. This is not large language model. This is embedding model, just like Ada, Babbage, or sentence transformer. Then I have two other models, Llama 3 and Phi 3. These two models are large language model. So I don't have Mistral. So what I can do is Olama. So I'm not using internet. Run phi 3. So if I'll run this command, it will start my phi 3 model. So I can, it is starting the model in a bit. Just a second. Yes. So the model is started. So I can ask any question, right? Okay, so it started writing this. So if I want to terminate this model, what I can, so this model is running locally. So if you are working with working with the clients who are from Middle East region, like Saudi Arabia or UAE, so so the clientele from Middle East, they are very concerned about their data security. So they are not willing to expose their data to OpenAI's servers. So they don't want to use any public cloud, or they don't want to push their data to any LLM, or they don't want to use any LLM with public cloud inference. So they, what they want is, they want to use a model which is locally hosted. So this is a very good option to host any LLM locally, Olama. So you simply install this Olama, you simply pull the model, and then you simply create this the package, and then you can install in on your local cloud system. So you can also terminate this. Just a second. So I have terminated this model. So by pressing Control D. So the command to terminate this model is Control D. Otherwise you can go here. Here you can see the sign of Olama. You can right click here and you can quit the model, right? So I can also download another model. Let me see which model I can download. So let's download any Mistral model. So Mistral 7 will with 4 GB. Okay. So I can download this model as well. Olama run Mistral. So you have to download Olama exe. Then you have to install the Olama, then simply run this command in the terminal. So it will start pulling the model. So the model size is 4.1 GB. That's why it is taking little bit time. And the second thing you can do is, so you need to install this Docker desktop. So if you have Docker desktop, go to the Docker desktop and search the image for quadrant. So quadrant is, let me show you what is quadrant. So quadrant is nothing but it is open source. It is open source, vector database. So you can install this open source vector database by following these commands. So if you go a little bit down, if you have installed the Docker, you can run this command in terminal. Docker pull quadrant, right? Otherwise, simply go to the Docker, search quadrant, and you can see this quadrant is running in terminal. So simply run this command in terminal. Quadrant
are going to wait for a minute. I guess there is some technical issues with Zaid.
Hello.
Zaid, can you hear us?
Yes, I can hear you. My screen is visible.
Yes, I'm going to fix it right now. Just a second. Yes.
Okay. So step one is download the Olama exe. Step two is install Olama. Step three is go to the terminal and run this command. and step 4 is download Docker desktop, and step 5 is pull image, pull and run image of quadrant slash quadrant. So quadrant is nothing but it's a vector database. It's a open source vector database. Okay, this is step number 5, and then this is step number 6. So this is step number 6. Okay, then the step number 7 is go to the documentation, and you don't need to run these commands. No need to run this command. So that's it. This is the final step. And the last thing is you have to run another command, which is olama origin, this command. So this is the last command. Step 7 is this. So I'm copying this, I'm sharing here. So I've shared all the commands in the group, right, guys? So everything is working. Let's start, the code. So I have already shared this notebook in the in the drive link which you have shared with me. So what we'll be doing here is we'll be using llama index. So you cannot use llama index directly like this. So you have to install pip install this command for llama embeddings, and you have to also install olama. So these are the commands which you have to you know let me send you these commands as well. So these are the commands to install different packages from the llama index. So if you have already installed llama index, that is not sufficient, because these are the different packages, and these packages are different, and then you also need to install these packages even if you have already installed llama index. So first you need to install the llama index, then you have to install the vector store quadrant, this, from the llama index. Then you have to store the file render, and then you have to install the embedding fast embed model, and then you also have to install this OpenAI, right? So if you are using OpenAI, because I'm not using OpenAI, you can ignore this, right? So I'm just sending this. So just ignore this. Install these packages as well. So I've shared these packages. So after installing these packages, you can simply run this code. In this code, I am just importing a directory reader from the llama index, vector store index, storage context, and get response synthesizers. So I'm importing also retriever query engine. So also the sentence splitter. So I'll be using this sentence splitter to split my text. So this is the PDF which I'll embed. Just let me show you the PDF. So this is the PDF. You can use any PDF, and this PDF I'll embed this PDF into my vector database, right? And then I'll ask question about this PDF, right? So you can use multiple PDF. I'm using one PDF. You can try this with 100 or maybe few hundred or few thousand PDFs. So if you have a good system, right? So I have imported some packages. I have also imported the quadrant client as well, right? So once you are done with importing these packages, then you have to create chunks. So what I'm doing here is, so I'm using simple directory reader. This is the package which I have, imported here. Simple directory reader. So I've shared this notebook. You can, run this notebook on your own. So before running this notebook, run all the commands which I have shared. First, follow all the steps. After following all the steps, install those packages of Llama Index. After installing those packages of Llama Index, you can, simply run this notebook. So after importing some packages, so I'm using simple directory reader. So this simple directory reader is a sub module of this Llama Index core. So in simple directory reader, I am giving path of the folder, and this is the folder path data. You can name anything. I have named it as a data folder, and within this data folder, I have a PDF file. So I have also provided the extension of the file, and then I've used this function show progress too. So it will show me the progress of the file, and then I've also provided the chunk size and chunk overlap. So what is chunk size and what is chunk overlap? Just let me open. So for example, this is my PDF, right? And in this PDF, I have, I converted this PDF into, few chunks like this. So let's say this is chunk number one, this is chunk number two, this is chunk number three. In first chunk, I have only, some, I have data like this. My name is Zaid, and this. So in chunk 3, I have this information. In chunk 4, my company, right? So what is chunk overlap? Chunk overlap will create, some overlapping. So let's say I'm using two words as a chunk overlap. So what it will be doing is, it will take all this text and two words from this text as well, right? And then it will create a chunk, right? So it will create chunks like this, okay? And then it will start, for the next chunk it will take these two words and then the next words, and for the next chunk it will also take these two words, and for the next chunk it will take also these two words. So by overlapping, it will try to maintain the relationship between the chunks. Otherwise, these chunks will be highly isolated and will not have any kind of relationship between the chunks. So if I'll not have any kind of a relationship between all those chunks, I will lose the consistency of the information. I will lose the relationship between the different chunks, and I'll not be able to extract right information from the documents. So for example, if I ask question, what is the company name of, what is the Zad's company name? So if I'll not have chunk overlap, it will not be able to answer this question, because then there will be no relationship between this chunk and this chunk, right? So we have to maintain a chain. So to maintain that chain, we have to define the chunk size. So that's why I'm saying the chunk size is 512, that take 512 tokens and then take 100 tokens as a chunk overlap. So then it will create three lists: chunk, text chunk, document IDs, and nodes. So I'll use this document IDs and nodes as a metadata. So you can perform two type of queries over your data. One type of query is exact keyword based search. So one query is keyword based search, right? And the second, this is conventional method. Second query is semantic search, and the third query is hybrid search, right? So the keyword based search, what it will be doing if we are performing keyword based search, it will try to find the exact match. So for example, if there is written data scientist in my query, it will try to match data scientist with each chunk. So it will say, okay, this this chunk is matching with the query, so it will perform the exact match. What semantic search will do, it will try to match those chunks having similar meaning. So for example, if I'm saying I am having coffee or I am having tea, so it will try to provide me these type of chunks having similar meanings. So this is where embeddings comes into the picture. So in hybrid search, we combine both type of search. So we combine in hybrid search we combine keyword based search and semantic search just to improve our search results, right? So that's why we are using the metadata like the document ID and nodes. So I have created the nodes, I have created the metadata, and I have also created the text chunks. So then I have to provide the port number here. So I am trying to create the client of my vector database. So what is the IP of the vector database? That is localhost, right? Because my vector database is running on localhost, and the port number is 6333. That is port number. So I have to provide the port number, I have to provide the IP to create the client of quadrant database. Then I instantiated the quadrant vector store by providing the client, and then you can provide any name of your collection name. So you can write judgment, you can write whatever, like so because I am using a data, and this data set is nothing but a judgment of the Supreme Court of Pakistan. So that's why I call this collection judgment. So if you can see here in my quadrant database, mm, voice training, quadrant data. So this is the folder which I have provided while which I have provided here, the link of the folder, the path. I have provided the path here. Just a second, guys. Right, in this command. So this is the command where I provided the path of that folder where I'll keep the data, quadrant data. So if I'll go to the collection, you can see the judgment folder. Otherwise, you can name it with different name. Like I can name it with judgment 2. Okay. Let's see if it is able to instantiate judgment 2 or not. Okay. Connection error. So because it refused the connection, just let me hold on. So guys, you will be getting this kind of errors as well. So if you are getting this error, what you have to do is you have to run this command, and B, just a second. So B, what you can do is you can go back to the quadrant, and you can follow these steps again. So now I am directly pulling this, right?
Uh, Tell me,
Yeah.
please, Zaid, there is another method to install Quadrant without Docker?
Yes, without, I mean, I'm not starting without Docker, but I am instantiating Docker from my terminal. I'm not using Docker. It is already running here, but because I'm not able to access it, so I am starting it from my terminal. So you are saying, is there any method without Docker? Hello. So you can install the binaries if you want to start without Docker. And just a second. So this command and then the path. So in this path, I have to go here. So my folder name is, just a second. Okay, content data. So run this command. Just a second. Let me copy command from here. Storage. Just a second. Yes. Quadrant. Quadrant. Just a second. No, it will again throw error. So I have to manually write this command. Yes. Just quadrant storage data user CPU. Docker invalid reference customers in your case. Okay. Yes. Yes. But it shouldn't be done. Yes. Yes. Invalid reference repository must be in lower cases. Let's fix this using ChatGPT. So guys, yes, guys, just a second. So what we can do is I can just write C. Just a second. C, C slash. Let's see if it works. V is not recognized. Oh God. Just a second. So I need to fix this issue. I don't know why this command is not running. I need to log fix this issue. No, no. Still, I'm getting the same error. Yes. Okay, I'll fix this error. I'll share this code with you. I'll fix this error and I'll let you know about the command. So you'll instantiate. You'll create a client of quadrant system. I'll fix this command. I'll share the command with you. This is the same command. There is a little mistake. I don't know what that mistake is, but I'll fix it later. So then what you have to do is you have to use the embedding model which you have. So if I'll go to O llama list, O llama list. So I have this embedding model. So how you can get this embedding model? You can simply run command O llama run and the name of this model, and the model's name is this, right? So you have to get this model. O llama run. Just so this is the command O llama pull, not run. So Olama pull this model, right? So you can simply by running this command, you can simply pull this model because I already have this model. So that's why I'm not pulling this model. And then you have to provide the base URL. So this URL is where your Olama is running. So if you have downloaded the Olama, so you can go to this localhost 11434 localhost. So you'll get this Olama running, right? So if you'll write this port 11434 with localhost, you'll get this Olama running, right? So you have to provide this here as well. So this is the port and the IP and port where your Olama is running. Then you also have to provide this embedding model name, and you also have to provide the name of the model. So for example, if you have not downloaded file 3, you will not be able to run this file 3, right? And you have to provide the embedding model address. Then you also have to provide the LLM's address. So your embeddings model address and LLM's address is same, And this, this timeout, request timeout is very important because you are running model locally. So always try to give at least 3 to 5 minutes timeout request, because otherwise it will get timeout and it will not provide you the answer, right? So you have instantiated your embedding model, you have instantiated your large language model both, right? And you also have created a client of vector database, right? Then what you can do is you can simply query your model, and you have to enumerate your documents. So I am right now I am having only one document, so this code will enumerate over the document. And for example, let's say you have 100 documents, it will create the chunks, and it will create the chunks by using the same logic which you have already provided, like the chunk overlap and the chunk size. It will create the chunks, then it will enumerate on each chunk, and it will get the metadata nodes. So it will get the metadata nodes like page number, document number, etc. It will store the IDs and the metadata nodes. Then it will enumerate over each node, and it will create the embeddings of those nodes as well, like node embedding. So it will create the text embedding, it will create the node embedding. Then after creating those embeddings, it will create a storage context and store all the information into a collection, right? And this collection will look something like this. So within this collection, so you'll have different segments, like these segments. In each segment, you have indexes, you have nodes, you have node embedding, everything, right? So then it will instantiate the vector index retriever, and you can set the k, similarity top k. So similarity top k means it will extract the top five similar chunks based on your query. Then it will create a retriever query engine. So retriever query engine can be used to to create memory type of things. If you want to create the memory after retrieving some chunks. So for example, just like chat gpt, if you have asked a question like 5 minutes ago, it will keep that question, the question and the answer of that question in a cache maybe, to use that question and answer as a memory, right? To answer your next question. Then it is you. Then right here I'm using hide query transformer. So you guys have to search about it. What is hide query transformer? So it will create some synthetic queries and some synthetic answers using your data. So it will transform your data by using hide query transformer. So it will transform your query to create further queries, similar queries. And in similar fashion, it will also transform your chunks to create further synthetic chunks. Then it will retrieve the answer. So here I have asked the question, what is 18th amendment? So this document is related to 18th amendment. So the so it this document is related to 18th amendment. So it will take my question, it will go to the vector database, it will find top 5 chunks, then it will concatenate those 5 chunks with my question, and then it will provide this context like, hey, this is my question, these are the top 5 documents which are related to my question, please answer this question by using this context. Then my large language model, I'm not using large language model, I'm using Phi, which is small language model. It will answer my question like, this document outlines the legal order related to 18th amendment, discussing various petitions and concerns regarding its provisions and impact on certain articles of the constitution. So it provided me a very good answer. So this is how you can use a large language model locally by using Olama. Then you can also use Quadrant, which is open source vector database, by using Docker, or by using Docker desktop or directly from your terminal. And then you can set up a RAG pipeline. And then on top of that, you can use Hide to create synthetic queries and synthetic chunks. So you that's it. This is it about the session. So what you can do is, this is simply about extraction. So initially the discussion was started from the classification. So what you can do is, you can create enhancements in this project. I have already shared this notebook. You can, first of all, you have to classify the documents. So for example, just one last point. So for example, you are receiving some legal documents, right? So you are receiving some legal documents as attachment in your emails, right? So what you have to do is, so there is team of 20 persons who is manually validating those legal documents daily basis. So what you can do is, by using this same notebook, you can create another feature of classification on top of that. So first of all, if a query comes in, you have to classify either this document which is attached with the email is valid or not valid, just like spam or not spam, is valid or not valid. This is document classification part. You can use LLM, you can use speci, you can use sentence transformer, anything, it is your choice. So first of all, you need to classify the document, either this document is valid or not valid. If document is not valid, then this is the end of the flow. You can simply respond back that the attached document is not valid. If document is valid, then you have to create chunks of that documents, or maybe extract information from the document and create chunks, and then you can store those chunks into a vector database, and then you can simply perform, maybe NER or QA. So NER is name entity recognition. So is this document related to a particular person or not? So for example, I have attached my identity card, right over, and I have attached identity card. So first of all, it should validate by using this classification model, either it is identity card or not. So if it's identity card, it should extract the information from my identity card and then store that information into a vector database, and then based on the question, it should validate this information with another database. Like we have already we have like company database, where we have all the information of the identity cards. So it extracted the information and it validated the information by matching the information from that particular database. So this can be another use case. So you can, create some interesting use cases by using this same pipeline. So that's it about this session, guys. If you have any question, you can ask. I'll share the correct command in a bit.
Okay. Thank you so much, Zaid. It's a very informative session. And actually, I want to say something because I remember the first time we done our first session with you, and even though it wasn't really a well organized session, but you still believed in us. You keep in touch, and now it's more than 4 sessions together. So thank you so much for supporting us. You'll always remain our first supporter.
Thank you, no problem. So
And
thank you for having.
thank you.
Take care, guys. Allah Hafiz.
Thank you. Thank you. And thank you to Baha
Yeah.
and Muhannad and Asma for being here too.
No,
Yeah, thank you.
thank you for you thank you for you too, Kauchar, for all the technical works that you do in the MDS Talks teams. Thank you to Asma. Thank you to
No
Muhannad.
problem. But these sessions was not up to my expectations. I was trying to, deliver uh, more comprehensive, type of knowledge. But there were so many things
Yeah, but
scattered here and there. I tried, and inshallah, next time we'll try to make it more
Inshallah.
comprehensive. Hope you
Inshallah.
will
Thank you so
understand.
much,
yeah,
Zaid,
of
again.
course. And thank you for the Sadaqa Jariya, Zaid. Thank you again. You
Thank you.
are
Thank you,
always
guys. Thank
welcome
you.
between us, bro.
Allah.
Thank you. See you next session, inshallah.
Subtiak.
ان شاء الله.
شكون غيجي شكون؟
سعيد وحيد ان شاء الله.
لانونس ديال سامدي شكون فيها؟
سيري اسماء.
يلا جود نايت تشاو.